Hi, welcome back. So we are in Chapter 6, Prediction by RCC, the outline Prediction by Classification, to discuss a new algorithm for classification problem that is the key nearest neighbor in this two-dimension here. And you're asked to actually predict what is the label of this. So the basic idea of the key neighbors, it says, well, in this X, all the data points, like say I have 1, 2, 3, all the way to n data point, and split them to the corresponding label. Say, for example, I would have the red label, and then you have the other class, for example, the yellow one here. And then you take this new point that we're talking about. We're going to measure based on the Euclidean distance between this new point and every point in that X matrix. Then basically what you will end up with, the red correspond to the red labels and the second one for the yellow labels. So you will have the first distance here, the second distance, and so on and so forth. Depends on the size of how many red label. And same thing for the yellow distance, 1, 2, all the way to how many yellow distances are in there. Actually, what we want to do is we want to look at the closest or the minimum distance value. That's why maybe it's called the K neighbors. So K, it indicates how many neighbors you are interested to return the closest distance to it. For example, if I say, well, I will set K to be equal to 3. What is the closest 3 distances to this particular new point? It's an odd number, so basically absolutely one of the classes will win. Out of these 3 neighbors, we could recommend this label to be the winner. This is the basic idea, I mean the framework of it. No any parametric consideration of variability, for example. And in some field, maybe if you go up with the K neighbors, that means tolerance of your mistake that you label it wrong. That was all actually considering the prediction by K nearest neighbor. We're going to take further step by discussing the next type of algorithm called the decision tree. I'll see you then.